Lesson 8.5 we're going to look at. It's technically called summarizing data using measures of variability. A lot of what we're going to be talking about just is going to deal with interquartile range. So we're actually going to skip over to page 483, example 2. So on example 2, it actually talks about interquartile range, which can be abbreviated as IQR. And it's the difference between the third quartile and the first quartile. So third quartile and first quartile are at the ends of our boxes. So in this case, 82 is our third quartile, 79 is our first quartile. So the difference between those, we would just be subtracting those, which your book shows down a little bit further here. Just subtract those would be 3. What that does, it gives us an idea, actually, of how spread out the middle 50% is. Spread out, 2 words there. But anyway, remember each section in a box plot or box and whisker plot represents 25%. So if we have both boxes and we're taking the difference between the low end and the high end of both of those boxes, that's really telling, how spread out the 50% in the middle 50% of numbers would be. So in this case, there was some numbers here on a dot plot, and it said, how can Anne determine the variability in her science quiz scores? So that's what they did. And then they said at least half of Anne's quiz scores were within 3 points. Another thing we could look at that might be valuable, we've already talked about, is the range. So the range, actually, we would be looking at, I know the book doesn't mention this, the range would be from the lowest number to the highest number. How much difference is there? So that would be 84 minus 78. So that would be 6. So we could say overall, all of her quiz scores were within 6 points, within 6%. Okay? So that seems pretty consistent. If the grades were all within 6 points of each other, 6%. Consistency in this case could be a good thing, it could be a bad thing. And that may just depend on what your standard is of a good or bad grade. All of her grades were between 78 and 84. So pretty consistent, but you could argue maybe she could have been a little more consistently good than consistently average, maybe, as what she's being here. So let's look at the try it. So we have a dot plot that shows distribution of Anne's health quiz scores, and how can the IQR, which is again the interquartile range, describe her scores. It specifically said on the question, how can the interquartile range describe her scores? So that's all we're going to look at is the interquartile range here. So in order to work this out, we are going to have to actually make a box plot or a box and whisker plot, because interquartile range, we have to know at least anyway what our first and third quartiles are. I guess you wouldn't technically have to draw the box plot out if you didn't want to, but so you can either look at the dots here. If you want to list them out, you can, if you find that helpful. You can list out all these scores. And then remember, if we were going to make a box plot or a box and whisker plot, once we put these in order, we would need to find first the median. So the median here would be 90. We just have one middle number. There were 7 numbers altogether. And then for the first quartile, remember, we're going to look at the numbers below the median, and we're going to find the median of those numbers. So 84, 86, and 88 are the numbers below that median. The median of those, our middle number there is 86. So 86 would be our first quartile. And that's an important point. And then we're going to find our third quartile. So above the median, we have 3 numbers there as well. And so we just have one middle number, 92. So 92 would be the third quartile. Sometimes called the upper quartile, if I ever call it that. Some books name them differently. All right, so now that we know those things, technically even without drawing the box plot or the box and whisker plot, we could figure out what our interquartile range or IQR is. Again, it's the difference between the first quartile and third quartile. So the difference here, we would be taking 92 minus 86. And when you subtract those is 6. So 6 is our interquartile range. And again, that's talking about the middle 50%. So in the middle 50%, then we could say that at least half of Ann's scores are within 6 points. In this one, again, pretty consistent, a little bit better scores on this, looks like, than what she had maybe on the science quiz scores. Example 3 we are skipping. It talks about mean absolute deviation. That's not one of our 6th grade standards, so we'll talk about that next year, actually 7th grade standard. So the try it we can look at though, because it talks about IQR again. So it says Jonah's team scored these amounts of points the last 9 games. Find the interquartile range and the range of the points Jonah's team scored in the last 9 games. Are these good measures for describing the points scored? So probably a good idea for us to start out would be to write the numbers in order from least to greatest. Actually, they've already done that for us this time. Even though they've already done this, if you want to, just rewrite the numbers so you've got a little bit of space here to work with. May not be a bad choice, although you don't have quite as much space maybe to work with on your paper as I do up here. One nice thing on this problem is that they told us this was in the last 9 games. So there should be 9 numbers here, and that gives me a hint as far as the median and things like that, knowing whether there's going to be 1 middle number or 2. So I do have 1 for sure middle number here, which is 41. So 41 is going to be the median. So that leaves me with 4 numbers below the median. That's an even amount, so I actually have 2 middle numbers here. So 37 and 38 are my 2 middle numbers. We can either think about, if they're close to each other like these are, you might be able to think about what's halfway between those, or otherwise you can average them out, adding and dividing by 2. Either way you do that, you get 37.5 or 37 and 5/10 for the first quartile. For the third quartile, we also have 2 numbers that are in the middle. We have these 4 numbers above. The 2 middle numbers here, though, are both 47. So you can do this if you want, but if you average 47 and 47, you'll get 47. So 47 is the third quartile. Okay, at this point, most of the work is done for this problem. We've done most of what we needed to. Just a couple more things to finish this off. So now to find our interquartile range, or IQR, we just need to subtract these. Remember, when you subtract, you need to line up your decimal points. 47, we don't see a decimal point, means it's after the 7. And so that we can put a 0 after the decimal. 47 and 0/10, same as 47. So in order to subtract this, we can't take 5 away from 0 with subtracting this, so we need to borrow. So we'll change the 7 to a 6. Put a 1 in front of our 0 there. Okay, 10/10 is the same as 1 whole that we borrowed. And then we can subtract. Once we get to this point, we're stuck again for a second because we can't do 6 minus 7, so we'll have to borrow again. Then we subtract that. 16 minus 7 is 9. So 9 and 5/10 would be our interquartile range, or IQR. They also asked us to find the range, so that was the more difficult work here. If you wanted to, you could have done this right away, really, the range. So to get that, we would just take the biggest number minus the smallest, so in this case 48 minus 36, which would be 12. So the range is 12. So we had an interquartile range of 9.5, 9.5, range of 12. And then it asked us, are these good measures for describing the points scored? So these are good measures for describing the points scored. IQR and range are close in value. It shows about half the data is clustered at each end. Really, a lot of this tells us, I mean, if you look at these, IQR and the range, IQR is not too far off from the range. So really what that's telling us, if you think about it, you know, without drawing this out too nicely here maybe, but really a big chunk of our difference is in that middle 50%. That middle 50% varies by 9.5, but overall we only vary by 12. So, you know, really between the top 25% and the bottom 25%, we're only having a variance of 2.5 altogether. So that kind of gives you an idea of which you could easily enough draw the box plot or box and whisker plot, but the box part is more spread out. That middle 50% is more spread out than the outside 50%. So page 484, we're going to look at a couple things on the do you know how. So 484, number 4. Davida works at a shoe store. She measured the feet of 9 customers, found their shoe sizes listed there. So number 4, they want us to find the mean. So we've done this before. So mean is another name for average. So in order to do that, we're going to have to add all the numbers together, and then we're going to have to divide by how many numbers we have. In this case, they actually told us in the problem that there were 9. So on this, even if we were allowed to use a calculator, we really should show our work of what we're doing. I'm just going to come over to the side here so I have a little bit more room to work. If you wanted to add these horizontally instead, you can. Okay. And again, I trust at this point you can add numbers. I know adding 9 numbers together is a little bit of a stretch maybe to do that very easily. But if we were doing this by hand, what I would be trying to do is look for, you know, like 4 and 6 add up to 10, 5 and 5 add up to 10, stuff like that. If you can find some pairs of things, that makes it a little bit easier to add. But anyway, for our purposes, as long as you show me what you're doing and that you are adding the numbers together, just to make it easier for you, quicker for you, if you want to use your calculator to add that. Again, I trust you could do it by hand if you had to. So we add these together would be 63. At that point, we'll take our total and divide by 9 since we had 9 numbers. And we would get 7. So our mean, or like average shoe size here is 7. Next, let's go down to number 7. So on 7, they want us to find the range and interquartile range, and they're asking how is each calculated. So we'll go ahead and answer the question about how they're calculated first of all, then we'll work these out. So again, the range is found by subtracting the minimum value from the maximum value, and the IQR is found by subtracting the first quartile from the third quartile. So for the range, we can just go ahead and take the biggest number minus the smallest, so 10 minus 4. So our range would be 6. Interquartile range, again, we've got a little bit more that we've got to work with that. So we had 9 numbers here, and so we do have one definite middle number, which is 7. So 7 would be our median. Our first quartile, we have 4 numbers below the median, so we have 2 middle numbers. So we're basically averaging 5 and 5, which is going to be 5. So first quartile is going to be 5. Again, if you want to add 5 plus 5 is 10, divided by 2 is 5. Third quartile, similar story here. We've got 4 numbers above the median, so we have 2 middle numbers. So we're going to average out 8 and 10, or you can think about halfway between 8 and 10 maybe, would be 9. And that's our third quartile. So third quartile is 9. So 9 minus 5 is 4. So 4 would be our interquartile range. Okay, so again, range overall, the variation was 6. Interquartile range, the middle 50% varied by 4.